Hello everyone, in this video I'll be explaining you the problem minimum number of flips to reverse binary string, and it was asked in biweekly contest 170. So let's read out the problem. You are given a positive integer n. Okay, so they've given positive integer n. Let s be the binary representation of n without leading zeros. Okay, yeah, we'll have to convert this decimal n into binary. Okay, the reverse of the binary string s is obtained by writing the characters of s in opposite order. You may flip any bit in s, basically changing 0 to 1 or 1 to 0. Each flip affects exactly 1 bit. Okay, yeah, like it is obvious, if you flip 1 bit it will affect only 1 bit. So return the minimum number of flips required to make s equal to the reverse of its original. Okay, got it. So yeah, I'll be telling you on the board, don't worry. So we have 7 and 10 as examples. So let's look into them. We have 7 and 10, right? So n is equal to 7 we have, and in the second example n is equal to 10 we have. So let me explain you the problem, what they're saying. They'll give integer n, it is integer. So we'll have to convert this into binary. So once you convert into binary, so that you can represent in a string s, right? Now what you need to do is, this is the original string. Okay, now you have to reverse this string, the binary string, right? Whatever binary string we have, we'll have to reverse it. Let me call it as rv, and this is the reverse string. Now we'll have to compare, this is the original string and this is the reverse string. So both are equal or not. If they're not equal, so you need to flip each bits to make equal, right? So the number of flips that you will be making, right, that will have to return, and that has to be minimum. So this is I think this minimum number is not very effective here. The reason being is simply they have asked you to confuse. So whatever string you will get in the binary representation of n, so that is the string without leading zeros you will be having. And when you reverse that, so whatever string you will be getting here, you will have to compare each bit. If let's say first bit is not equals to the first bit of reverse, then you will have to flip this in order to make this reverse string equal to original string. So once you are doing that, which means you are doing one operation, right? So minimum number of operation you will have to do. So let's consider the first test case. N is 7, so in binary 7 can be written as 111. So you can also write string in this way. This is also correct 7, but leading zeros, why you need to take that? You just try to avoid this, because 7 is this also, like there will be 32 bits, right? So all 32 bits you don't need to take care of. So only the whatever leading zeros you're having, so that you can eradicate, I mean remove. So this is the string that now you have. Now you'll have to make this reverse string. So reverse this. Even if you reverse this, the string looks same. So now you have 3 bits, here also 3 bits. If you compare this with this 0th bit, first bit and second bit, all are having equal value. So in this case, no flip is required, right? So your answer is going to be 0 in this case. So yeah, in the first case answer is 0. Let's try to consider the second test case. So now n is 10 in the second test case. So 10 in binary can be represented as 1010, right? So those who don't know how to convert integer to binary, so what we can do is, you can take 10 and always divide it by 2. When you divide it by 2, so it is going to be 5, because 2 divides 10 and then your quotient is 5, and then remainder is going to be 0 here, right? It's like 10 by 2, when you're doing 2 ones are 2 5s are, and remainder is 0. Now again you divide it by 2, so it is going to be 2 2s are 4 and 1 is the remainder. Now again you divide it by 2, sorry, 2 2s are 4, it was not 4. So 2 1s are 2 and remainder is 0, right? Now whatever value you got, 1010, right? So take in this way, this will be your binary representation of 10. So 1010 is your binary representation of 10. So it's easy only, I think those who don't know, for them I'm saying. Now try to reverse the string. RV I'll take 0 will be here, 1 will be here, 0 1. So once you reverse the string, basically reversing means reading from right to left. So this is going to be a string. Now compare each bit. When you're comparing, see, these are not equal, so you need to flip this. So answer is going to be initially 0 once you flip this. So now one flip you have done. Okay, now you have 1 1 0 1 as the reverse string. So 1 and 0 is again, it is not equal, so flip this. So once you flip this, it is going to be this thing. Now 2 times you have flipped. Now compare third bit. Say 0th bit equal, second bit equal, first bit equal, now second bit are not equal. So now again flip this. Now it is going to be this thing, and we have made 3 flips. Now again, if you compare this with this, now it is not equal, flip this. So 4 operation when you do, so your string is going to be 1010, and this is equal to the original string. So I think you guys understood. In this problem, only thing is you'll have to convert, binary integer into not binary integer, sorry, integer into binary of its representation, and that I think you guys know, or if you don't know, just divide it by 2. Whenever there is no reminder, then it is going to be 0. Whenever there is a reminder, it is going to be 1. And that is the thing. Once you have string, now try to take one more RV as a string and then reverse it, and now start comparing each bit. If it is not equal, then your answer is going to increase by 1. So yeah, that's it about the problem. Let's try to code it up. So first, let's try to take string s, and initially it will be empty. Now what you need to do is convert integer to binary. What you'll have to do is take a loop while n is greater than 0. So you'll have to run this loop, and then you see if this n modulo 2, if it is having 1 as a reminder, so in that case your string has to be added with 1. Else there is no reminder, which means n modulo 2 equals to 0. So if it is not having any reminder, so 0 will be added into the string. And don't try to forget divide it by 2. So those who know bitwise operation, what we can do is we can left shift by 1, right? And then this AND comparison, what we can do is you can AND with 1. So this will also give a same thing. So once you have that string, now try to take reverse string. Initially initialize to string s. Now reverse the string rv, right? Once you reverse this, now take one answer variable, initially 0, and run till you have all the elements, I mean s till the size of the string s. Now start comparing. If s of I not equals to reverse string of I, I just put rv, never mind, it has to be rs or something like that. So now your answer is going to be increased by 1. At the end, try to return the answer. Let's try to run it. Here it is getting wrong. Why is it so? Let me just check. We have string s initially 0, while we have n. You are checking if last bit is set, then s is going to be 1, else s is going to be 0, and right shift the n by 1. Take string reverse string, okay, and then I'm reversing. Oh my bad, see, in if condition it shouldn't have semicolon, my bad, because it was like outside of if statement, and that's why Every time we entered into this loop, we were getting increased by 1. Let's try to submit it. Yeah, it got accepted and it beats 100% of the user. So yeah, in this way you could have easily solved the problem. And let's analyze the time complexity of this. So n is going to be integer. So integer, in bitwise representation, it is going to take 32 bits. So this loop will run till 32 at max, not more than that. So which is constant. Then you have string s, which is also of size 32 only. You're reversing it, so this is going to be linear, and then which is also constant 32, and this is also going to be 32 at max, not more than that. So both time and space complexity are constant in this case. So yeah, thank you guys for watching the video.